So now let us learn diffraction through combination of medium. You see, there are three mediums which are in contact with each other. This is medium 1, this is medium 2, this is medium 2, this is medium 3. So now a ray of light is traveling through these mediums. It will undergo refraction at three interfaces. So this is the ray of light, this is the normal, here it undergoes refraction, reach the second interface between the medium 2 and 3, and again undergoes refraction, reach the third medium, third interface, and then again undergoes refraction and comes out parallel to the incident ray. Parallel to this one. So let's say this is angle of incidence I, this is angle of refraction R1. So you can see this angle and this angle will be same because they are alternate angles. So this is also R1. Let's say this angle is R2, this is R2, means this is also R2. Finally this angle and I will be same. So this is as Y, they will be same, not necessarily that in all cases it has to be same. If you look closely, all of these interfaces are parallel to each other. So as they parallel, so both the I are equal. So as they're equal, so now let me name the interface. This is X, Y, this is X dash, Y dash, this is X double dash, Y double dash. So at XY, at the interface XY, what can we write? Sin I by sin of R equal to, so N1, N2, N3 are the refractive indexes of the three mediums. So what can I write? It is going from 1 to 2, so it must be written as N2 by N1, which means it is going from 1 and going into 2. This is my equation 1. This is equation 1. Similarly, at X prime, Y prime, what can I write? Sin I by sin of, this is R1, this is also R1, sin of I by R1 is equal to what it should be? It should be, it is going from 2 to 3. So N3 by N2 equal to going from 2 to 3, N3. This is equation 2. Fine. Let me write the last one. Now for the next one, that is at X double prime, Y double prime, we can write, you see, it is sin of R2 by sin of I. So sin of R2 by sin of I equal to, it is going from 3 to 1. So N3 by N1, always in a numerator it will be always the medium in which the ray is traveling into, remember that. And in the notation we will write 1, it is going from 3 to 1. This is equation 3. So now if I multiply 1 into 2 into 3, let's see what do we get. So sin I by sine of r1 into sine of r1 by sine of r2 into sine of r2 by sine of I equal to 1 n2 into 2 n3, and then this one is 3 n1. Again the left hand side reduces to 1. You can see all of them will get cancelled out. So we can write 1 n2 into 2 n3 into 3 n1 equal to 1. Now let's say let 1, the medium 1 is air, medium 2 is water, medium 3 is glass. So our relation is 1 n2 1 n2 into 2 n3 2 n3 into 3 n1 3 n1 equals to 1. Now if let us take a side note here, you see, so 1 n2 can be written as what? Air to glass, right, which is my 1 n2. Then 2 n3 will be what? Water to glass, which is 2 n3, and the last one is 3 n1, which is glass, sorry, so last one is from glass to air, glass to air, which is our 3 n1, correct. So 2 n3, how can I write 2 n3? 2 n3 can be written as 1 by 1 n2 into 2 into 3 n1. Now 3 n1 is what? You are trying to find the absolute refractive, you have to find relative refractive index of air with respect to glass, but air is 1 only, no? So it would be what? It would be good if we find what is the absolute refractive index of glass with respect to, what is the refractive index of glass with respect to air, rather than what is the refractive index of air with respect to glass. So what we can do, we can change this, because this one is definitely absolute refractive index of water, but this is not the absolute refractive index of water. This is the absolute, this is what do you call it? It will be relative refractive index of air with respect to glass. So this is of no use. So let us, what you can do, using principle of reversibility, principle of reversibility, that is 1 n2 is equal to 1 by 2 n1 3 n1 is equal to how much? 1 by 1 n3, right? So if I plug this relation here, if I substitute this one here, then the relation becomes 2n3 is equal to 1n3 divided by 1n2, which is, well, this is the, or if I simplify it and write, 2 is water, so water n glass is equal to absolute refractive index of glass by absolute refractive index of water. So this is the relative refractive index, which we have already seen earlier, and now we have established the relation using principle of reversibility of light. Understand? We have seen earlier that if n glass is 1.5 and n water is 1.3, which we write this as 3 by 2 and this one as 4 by 3. So what is now water, glass with respect to water? So this one will be read as glass with respect to water. Remember that this is read as refractive, relative refractive index of glass with respect to water. Remember that. So will be written as water Ng, absolute refractive index of glass is 3 by 2 and that of water is 4 by 3. That gives me 9 by 8. I hope you understood. So let me show you this picture, the first picture. Let us see this in our physics engine. Let us see this picture in our physics engine. You can see I have set up the structure here. This is our ray of light. This is the laser I am using. This is water. This is glass. And you can see one thing you must note here is that as these interfaces are all parallel to each other, so this ray will be parallel to its original path. What I mean is that if I draw one line here, this is the original path of the ray. This one and this one are parallel, and if I draw one perpendicular from here, this is called the lateral shift. We will find out the value of the lateral shift in one of my videos also. So I hope you have understood. For any doubt, you can leave, for any question or any doubt, you can leave that in the comments. And if you have liked it, please don't forget to like it, share it and subscribe it. Thank you.